Hello guys, let's talk about combustion analysis. It is a very handy tool because if you remember when we are burning a substance, we are using oxygen gas, and if our substance or sample contains only carbon and hydrogen atoms, or hydrogen, carbon, and oxygen atoms, the products are always CO2 and H2O, carbon dioxide and water. So, if we can measure the amount of carbon dioxide and water produced in this combustion process, we can actually figure out the formula of our sample. Let me show you how to do that using a practice problem. So here we are given 1.97 grams of a sample of an unknown that contains carbon, hydrogen, and oxygen atoms. And the combustion analysis yielded 3.80 grams of CO2 and 2.14 grams of water. And we have to determine the empirical formula for the compound. So let's think about what is happening during this process. We have 1.97 grams of a sample that contains carbon, hydrogen, and oxygen. We burn it, so we add extra oxygen to it. And on the other side, we produce 3.80 grams of carbon dioxide and 2.14 grams of H2O. Okay, now it is obvious from the amount of the products that we produced way more than what we had in the sample because we added extra oxygen atoms. Okay, we'll have to account for that. But how do I figure out the mass of carbon and hydrogen first? Well, if I know the amount of CO2, I can calculate the moles of CO2, and from there, I can calculate the grams of carbon in my sample. I can do the same thing for water and calculate the grams of hydrogen in my sample. Now, if I know the grams of carbon and hydrogen, I can simply take the mass of my sample and subtract from that the grams of carbon and grams of hydrogen to get the grams of oxygen without taking into account the amount of extra oxygen that I used for burning. Okay, so let's take a look at how to do this step by step. I am going to start with figuring out how much carbon was in my original sample using the amount of CO2. So first, I have 3.80 grams of CO2. In order to get the grams of carbon, I have to convert the grams of CO2 into moles of CO2. So grams of CO2 into moles of CO2. I know that 1 mole of CO2 is actually 44.01 grams, and this is just the molar mass of carbon dioxide. Now I have the moles of CO2 and I want to go to the moles of carbon. So moles of CO2 and moles of carbon. Since I know that in each molecule of CO2, I have 1 carbon atom, the mole ratio is also going to be 1 to 1. Now, if I have the moles of carbon, I can convert that into grams of carbon. So in 1 mole, I have 12.01 grams of carbon. Okay, so if you do this calculation, you are going to arrive to 1.04 grams of carbon. Okay, let's do the same thing for the grams of hydrogen. So we started with 2.14 grams of water, and we want to go from grams of water into moles of water. Sometimes I actually write the whole thing out and add the numbers later, We can actually try doing that. You can try doing that too because it makes a good logical sequence. So we went from grams to moles of water. We have to convert the moles of water into moles of hydrogen, and then the moles of hydrogen into grams of hydrogen. And now I just add in the numbers. So 1 mole of H2O is actually 18.01 gram, which is the molar mass of water. I know that in each H2O molecule, I have 2 hydrogen atoms. So the mole ratio is 1 mole of H2O to 2 moles of hydrogen. And then I know that in 1 mole of hydrogen, I have 1.01 grams, right? And that comes just simply from the periodic table. So if I do this calculation, I'm going to get 0.24 grams of hydrogen. All right, so I know the grams of carbon, I know the grams of hydrogen. In order to figure out the grams of oxygen, I need to take the grams of the sample and subtract the grams of carbon and hydrogen from it. So 1.97 grams minus 1.04 grams of carbon minus 0.24 grams of hydrogen will give me 0.69 grams of oxygen. Okay, so now I know the grams of carbon, oxygen, and hydrogen, so I can calculate the number of moles to get, again, the mole ratios to figure out the empirical formula as we did before. So let's do that on the next slide. So if I have 1.04 grams of carbon, which I calculated on the previous slide, I can convert that into moles by using the conversion factor from grams of carbon to moles of carbon. So 1 mole of carbon is actually 12.01 grams. So if you do this calculation, you are going to get 0.087 moles of carbon. I'm gonna do the same thing for hydrogen. So on the previous slide, I calculated that I have 0.24 grams of hydrogen. So grams of hydrogen into moles of hydrogen. So 1 mole is 1.01 gram, which is going to give me 0.24 mole of hydrogen. And I can calculate the moles of oxygen using the 0.69 grams of oxygen that I also calculated on the previous slide. Grams of oxygen on the bottom, moles of oxygen on top. 1 mole is 16.00 grams. So that is going to give me 0.043 moles of oxygen atoms. Okay, so now if you remember, as we did before, you simply need to find the element with the smallest number of moles. Which one has the smallest number of moles in this case? Oxygen, right? So here we have oxygen with 0.043 moles. And then we have to divide the other two amounts of moles by this to get the mole ratio and also the ratio of the atoms in the empirical formula. So I'm going to do the calculation first for carbon. So I take 0.087 moles of carbon divided by 0.043 moles of oxygen, and I'm going to get 1.89, which can be rounded up to 2. Then for hydrogen, I take 0.24 moles of hydrogen divided by 0.043 moles of oxygen, and this is going to give me 5.58 as its ratio. Okay, so this number is really close to 5.5, so I'm going to keep it as 5.5. Okay, so based on the information that I have right now, I could write out the formula the following way. C2 H5.5O. Does this formula make sense? Can we have half a hydrogen atom in a formula? No, not really, right? So in order to actually get a whole number of hydrogen atoms, I have to multiply each one of those subscripts by 2. So that is going to give me C4H11O2. That makes way more sense than the 5.5 hydrogen atoms. Okay, so this is our final answer for the empirical formula of the compound. Okay, I hope this makes sense. See you in the next video.